I'm going to carry on right from this line. Now, put your pens down for a second. This proof, it's so mind-bogglingly fast that you can see it written down and follow every step, and it'll be over before you say, wait, what just happened? How did that just really do what I thought it did? Okay, so I'm going to go through it super slow. There's not that much to write, okay? Let's look at this line here, this line that I've set out, okay? Let me ask you two questions. Number one, for what values of n is this statement true? You know, we looked at extraneous solutions in algebra and that kind of thing. Sometimes statements are true for some values of x or whatever, and some it's not. What values of n is this true for? I've got a couple of restrictions, so far at least. First, I want n to be positive, right? Because if it's negative, I'm getting fractions and it's not going to happen, right? Secondly, I'm thinking, like, this is all in integer land, right? It's all in integer land. I haven't explored what happens when you look at like fractions and all that kind of thing, but I'm expecting if n was say equal to a half, this is going to be square root, right? Doesn't look like it's going to pan out for me, okay? So I'm saying, here's a fancy way of writing it, n has to be a positive integer. Don't get messed up on the notation if you're like, whoa, I've never seen that before. That's what it means. I'm telling you what it means. N is an integer that's positive. That's what it means, okay? All right, so there's a restriction on n. What about x? For what values of x is this statement true? Yeah, Nikita.
Isn't it the same as when you have polynomials? You can't have x being a negative number or a square root.
Let's think about that for a second. Okay, so you're looking at a polynomial here, right? Let's not just think of, you know, part of the problem with this is it's abstract. You're like, well, what is this really? Well, I've got an actual one right here. This is a polynomial. Maybe if you want to look at this one, for what values of x is that statement true? Because I've taken n out of the equation now. Yeah, I don't know.
Does the coefficient of x have to be 1?
You mean like this number at the front here? Let me pose that question to everyone, because I think you may have looked at some questions like this.
Yeah.
If I say this, what difference does that make?
You just times the whole thing by 2.
Yeah, well, so where I have x here, I'll have 2x. Where I have x squared here, I'll have 2x all squared, right? And then I'll have 2x all cubed. Still kind of works. The 1, 3, 3, 1, that pattern still forms. Let me put something to you. I think this statement is true for all values of x. I think it's always true. Even when you put in weird, wacky stuff into there, you think of a kind of number, positives, negatives, irrationals, transcendental, any number you like, you can put this in here, you can chuck it into your calculator. Go for it. Go 1 plus pi cubed. Okay, I'm going to put some money down that it's equal to 1 plus 3 pi plus 3 pi squared plus pi cubed, whatever that's equal to. Okay, I'm putting to you that this is always true. Okay? So therefore, I'm going to take a very pedestrian value of x. I'm going to say, how about x equals 1? That's a pretty ordinary number, right? Let's just see what happens. Before I do the left-hand side, I'm going to do the right-hand side. That's a bit weird. What's going to happen over here on the right-hand side? 1's important. 1 is useful. 1 has some properties when you raise it to a power, right? Because 1 to the power of 0 is going to be 1. And 1 to the power of 1 is going to be 1. And 1 squared, and 1 cubed, and 1 to the n. Right, you get it. And multiplying doesn't do anything. So in fact, all I get left with is the coefficients, right?
I need a good stop.
Do you seriously bring this phone in school?
Refocus. Refocus. Are you happy with my right-hand side so far?
Yeah.
Can you see I've just not written a whole bunch of 1s? Okay. Okay, fine. What does the left-hand side look like?
2 to the power of x plus 1. 1 plus 1.
What just happened? I told you it would go by so fast that you hardly even noticed. Have you ever seen a one-line proof in your life?
It's okay, so
Oh my goodness, look at the floor.
There he is.